Good morning, everybody. Welcome to another wonderful morning of chemistry, Chem 1105, with your host, me, Dr. White. All right, we got a fun-filled morning ahead, but first I have a question to ask of you all. Does anybody happen to think the air around you when you're breathing, do you think that's a mixture? Or did you happen to look at some water and think that's a compound? A chemical. Did you do that? Remember, it won't hurt to think about chemistry outside my class. It's everywhere. I had the whole semester to work on you guys, to have you think about chemistry outside my class. All right, important announcement. The lab I covered yesterday, don't forget that's due next Tuesday. It's an easy 10 points if you hand it in. If you don't and it's late, you'll get 0 points. I'd rather get 10 than 0. So don't forget to hand your labs in, please. All right, yesterday we were talking about temperature. Thumbs up, people. Do you see the temperature scale? Thank you. All right. There are 3 scales. One is Celsius, degrees C. Kelvin is an absolute scale, so there's no degrees. It's just K for Kelvin. And Fahrenheit, degrees F. You're probably most familiar with Fahrenheit. And if you drive around Chicagoland, you'll see a lot of signs, time and temperature, and you will see both Fahrenheit nowadays. They show Celsius also. Now, there's ways of going from one scale to other, otherwise known as conversion. And here are 3 formulas. Now, instead of going over this now and showing you how to do this, I'm going to wait until we finish the appendix A2, A4, because it involves using something called significant figures. So I'm going to skip this. Oh, no, look. Ooh, do you want to know a secret? Look at the lower left-hand corner of my screen, and you see page 28, or if I click on this, page 29 of 29, I finished a chapter. And you know what that means, everybody? It's time for a new chapter. Dr. White can be a wild and silly guy on Zoom, and I do. It's a new chapter time. Now, one of the more important things in science, especially chemistry, is dealing with numbers. Not only do you measure things, but when you do calculations with numbers. And there's a very important aspect of this. And let's look at that chapter, or appendix, really. And hopefully you all see appendix 2A, 4A on your screen. Now, this chapter deals with measurements. And also, it talks about the chapter title, problem solving. And we'll do a little today for this chapter. Now, I'll never ask you, but measurement is the determination of dimensions, capacity, quantity, or extent of something. You know, you want to measure how long something is, how much does something weigh, what's the volume, how much liquid you have, or gas, you can measure volume, and even solids. Now, chemists measure a lot of things. We measure mass, which is really weight, volume, length, time, temperature, pressure. I'll teach you later on concentration, how much of something is in something else, and other physical and chemical properties. The next time you go to a gas station, that octane number is something that's actually measured. How well something burns, and I'll teach you later a very important measurement called pH. And if you're in the chemical industry like mine, we measure a lot of other things, including color. color, measuring the color of something is very important, especially if you're using cosmetics. Ooh, quick, interesting note from Dr. White. A couple companies I worked for sold chemicals to cosmetic and personal care companies, which I dealt with at my position, like Neutrogena and others. And color, something we had to measure, was very important. Do you want to put something on your skin that looks like, oh, why is that a dark brown color when it should be clear? How do you know that doesn't happen? You measure color. Now, when you do a measurement, one of the things I want to teach you first is what happens if you get a very large number, I mean really large, or very, very, very tiny number. How do you write that? Well, chemists and scientists use scientific notation. And I will never ask you what is scientific notation, but it's a system in which an ordinary decimal number is expressed as a product of a number between 1 and 10 times 10 raised to a power. And it looks like this. Now, scientific notation, example 1.57 times 10 squared. Now let's just talk about 10 squared. Yes, we're going to do some math this semester. Relax, take a deep breath, let it out, take a deep breath, let it out. Any math we do, I will teach you how to do it. All right, what does 10 to the squared mean, or any power 10 to the n? It's 10 times 10 to the power here. So 10 squared equals 10 times 10, which is 100. If I did my math right. Oh, by the way, if I ever make a mistake, correct me, please. Now, 10 cubed is 10 times 10 times 10, which is 1,000. Now, if you had 10 to the 23rd, you'd have 23 tens and a very big number, which would take me a long time to write out 23 tens and a 1 with 22 zeros after it. I'm not going to do that because we have scientific notation. Now, an important skill you should know, hint, an important skill you should know is converting a decimal number to scientific notation. And how do you do that? Let's look at a number. Oh, let me change my mind. One thing I don't know if I mentioned, but I better mention it now. That's how I write my sevens. Back in high school, when I took German the first semester, we had a great German teacher who was from Germany. He was German. Herr Brink, here means Mr. Great teacher, funny as all hell too. And he wrote his sevens like this, which is the European way of writing a seven, German way for sure. I thought that was the coolest thing in the world, and I've been doing that ever since. So how do you write 1,357 in scientific notation? Step one, the decimal point in the decimal number is moved to the position to the right of the first zero, non-zero number. This should be non-zero. I guess zero is a zero number. That's a good question. Now, even if there's no decimal, you would do that. So let's assume there's a decimal point here. Even if there isn't, let's assume we move it 1, 2, 3 times to the right of the first non-zero number. And therefore, I'm going to write it 1.357 Now, it's times 10 to the power. The exponent, the n, 10 to the n, how do you figure out what is n? The exponent for the exponential term is equal to the number of places the decimal point has been moved. The exponent is positive if the number is greater than 10. The exponent is negative if the number is less than 1. Now, I'll never do this on a test, but if the number is 0, the exponent is 0, if the number is between 1 and 10, this I will never do on a test, but just to show you, 10 to the 0 equals the number 1. So let's go back and look at our example. How many times did we move it? 1, 2, 3. So this would be 1.357 times 10 to the third. Now, if there were any zeros and no decimal point at the end, we would drop those zeros. So guess what time it is? Let's practice converting. Now, I used to have from, but this I no longer teach because with a calculator, you're never going to have to do that in my class. In real life, you don't do that at all. But you do have to know how to go from a decimal number to scientific notation. And let's practice. To save time, I'm going to abbreviate. On a test, I wouldn't. By the way, PTS stands for points. How would you write this one? I'm going to do this one, then I'm going to let you have some fun too. Well, I have to move the decimal point, and if there was one, it's right here to the right of the first non-zero number. So I'll move it 1, 2, 3, 4, 5. Now, any zeros at the end, when there wasn't a decimal, which there wasn't a decimal point, you drop. So this is 2.13. Now it's 10 to the power. And what's the power there? How many times did we have to move it to the right of the decimal? 1, 2, 3, 4, 5. So this would be 2.13 times 10 to the fifth. Now, one important thing, this number here that you multiply times 10 to n or power is never less than 1, is never 10 or greater. This number here is never less than 1 and never 10 or greater. Oops, getting ahead of myself. Here's 56,800. It's your turn to have some fun. See, chemistry isn't that hard. Don't forget, in my class, there's no such thing as a dumb question. If anything I'm covering today or anytime during class, after class, or anytime you have a question, always feel free to ask. All right, let's assume everybody's done. Let's do this. How do you write this number in scientific notation? Well, there were decimal point, it would be here. and I'll move it to the right of the first non-zero number, 1, 2, 3, 4. Now, zeros at the end, when there wasn't a decimal, like our example, we drop. So this is 5.68. How many times do we move it? 1, 2, 3, 4. So it'd be times 10 to the fourth. Oh, this was fun. Let's do another one. Here's one more for you to have fun with. If I say fun enough time, you might believe me. See how sneaky I am? And for all of you who have your web camera on, thank you. Ooh, I see some people are already done. Haven't done this in a while. All right, I think everybody's done. So I better get to work. How do you write this in scientific notation? You move the decimal point to the right of the first non-zero number. And if there's no decimal point, you assume there would be one at the end. So I'll move it here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 times. Zeros at the end without a decimal are dropped. So this would be 3.47 times 10 to the nth. What is the n? The number of times we moved it. That was 7. And that's how you do scientific notation for a number that's greater than 10. Let's continue. I'll do this one. Now, here we have a number much lower than 1. So n will be negative, but we do the same thing. Here we actually have a decimal point. We move it to the right of the first non-zero number. 1, 2, 3, 4. Zeros at the front are dropped. So this would be 4.41 times 10. How many times do we move it? 1, 2, 3, 4. When the number is less than 1, n is negative. So we moved it 4 times, but now we put a minus sign, making it negative, and 4. So it's be 4.41 times 10 to the minus 4. Now I need to show you something else. When there's a 0 at the end after the decimal point, you do not drop it. When there's a 0 at the end after a decimal point, you don't drop this. So how do we write this in scientific notation? You take this number or the decimal point and move it to the right of the first non-zero number, 1, 2, 3. And therefore we will have 5.10. That's an awful looking 5. Let me do better. That's better, sort of. And then times 10 to the what? Well, this number is less than 1, and we moved it 3 times. And when the number is less than 1, n is negative. So it's going to be minus, making it negative, and we moved it 3 times. So it'd be 5.1 0 times 10 to the minus 3. All right, it's time for you to have some fun. And why don't you write this in scientific notation? Oh my goodness, a lot of you are getting the hang of it. Doesn't that feel good? Make me feel good. It does make me feel good. All right, anybody need more time? Going once, twice, let's do it. Here's the decimal point. How do you write it in scientific notation? You move the decimal point to the right of the first non-zero number. 1, 2, 3, 4, 5. We moved it 5 times. Lead zeros are dropped. So this would be 4.89 times 10. It's a negative number, therefore it's negative 5. Let's do one more. And there it is. Write that in scientific notation. And when you're done, if I were in class, I'd tell you, look up and smile. But since some of you don't have your webcams on, give me a thumbs up emoji when you're done. All right, I see a lot of people are done. By the way, I've been trying to get emoji renamed to symboli. Sort of a symbol, nah. All right, let's do this. Here's our decimal point. This number is less than 1, but either way, we move the decimal to the right of the first non-zero number. 1, 2. Now, all lead zeros I drop, 5.61. Zeros after the decimal point, we keep. And we moved it 1, 2, since it's less than 1. N is negative, therefore it's -2. And this is a skill you need to know. And in the chapter 2 practice problems, or chapter appendix A2, A4, there's practice of this for you. All right, let's continue on. Now, when you measure a number, like how long is something, how much does something weigh? Numbers you obtain when you measure a quantity such as weight, temperature, length. There's always uncertainty in every measurement. And I'll explain what this uncertainty means. I'll show you in a second, maybe more than a second. In any measurement, the last digit is always uncertain, but it's the only uncertain digit. And what do we mean by that? We talk about what's called significant figures. I'll never ask you what a significant figure is. When you get a number, there are 2 types of ways you can discuss that measurement. One is significant figures. That's the digit in any measurement that's known with certainty plus 1 digit that's uncertain. Now, there's another type of number called exact numbers. And these are numbers either obtained by counting or numbers that are in the definition, like the one I gave you earlier for converting temperature. There were exact numbers in those formulas. Let's look at significant figures and let me explain what this really means. Does everybody see what are significant figures on your screen right now? Thank you. Now notice I have 3 rulers here. The first one only measures from 0 to 100 centimeters. The second one does the same length, but you see it's measured in every 10 centimeters. And the last one is every 1 centimeter. If you were measuring that line with the top ruler, you'd say, well, that's about 20 or 30. Let's call it 20 centimeters, because I don't know any more specific. It's somewhere around 20 or 30. So I'd say 20. Now, the second ruler, I have more definition or it's more accurate. And now I could say, well, that's about 22 or 23. For this, I could only say it's 20 or 30. Here I can say it's 22 or 23, where my second number, 2 or 3, is I'm uncertain about it. Now, if we go to the bottom one, we can see the line is just past the 22, about halfway between 22 and 23 centimeters. And I could say, well, that's 22 point, I'll call it 5. So the first one, I could only say about 20, second one, 22, and the last one, 22.5. And notice as I go down those rulers, my measurement is more accurate. And that's an important part of significant figures. The more significant figures you have in a measurement, the more accurate it is. Now, when you have a number, it's important to determine that measurement or the number you're working with, how many significant figures there are in that measurement. And oh no, it's time for Dr. White to be subtle. Isn't it nice I can be subtle? And know this. Now, I'll never ask you to, what are the definitions for determining significant figures, but I will ask you to know how to use this. All right, let's go through this. All non-zero numbers are significant. So if I have a number like this, whoops, wrong color. Notice that number has all non-zero numbers. How many are there? Hopefully you all know how to count. And there's 1, 2, 3, 4. So this has 4 significant figures. And I'll abbreviate with SF. So all non-zero numbers are significant. I'm going to let you have a try. How many significant figures are in that number? Your turn. Remember, all non-zero numbers are significant. And time's up. Put down your pencil and pen. All right, we have 1, 2, 3, 4, 5 non-zero numbers. Therefore, this has 5 significant figures. Well, what about zeros? Well, zeros may or may not be significant. Boy, that wasn't too helpful. But let's talk about zeros. Lead zeros at the beginning of the number are never significant. Lead zeros at the beginning of the number are never significant. Now, I write my decimal, and you don't have to, but I like putting a 0 in front. And the question is, how many significant figures, and this is a skill you'll need for test 1, test 2, test 3, test 4, and the final. If you don't know how to do this, you're going to lose points on each of those tests. So make sure you pay attention. We'll practice this a lot. Lead zeros are never significant, so these are not. And all non-zero numbers are significant. Well, we've got 2 of them here, so therefore this has 2 significant figures. And why don't you try this one? How many significant figures are in that number? All right, I think, is everybody done? I'll give you 3.76 more seconds. 1, 2, 3, 3.2, 3.6, time's up. And let's take a look at this. Lead zeros are not considered significant ever, but non-zero numbers are. And we've got 1, 2, 3. So this would have 3 significant figures. Now let's continue on with zeros. Confined zeros, those zeros between non-zero numbers are significant. If we look at this number, the question is, how many significant figures are there? All non-zero numbers are significant. 1, 2, 3. Oh, look, we have a 0. It's between 2 non-zero numbers, and therefore it's significant. Therefore, this has 4 significant figures. Remember, zeros at the front are never significant. All non-zero numbers are, and zeros that are confined in between non-zero numbers are significant. So I'm running out of room. I better go to my whiteboard. And a test I might ask, and a test, I'd print this out. I wouldn't abbreviate. How many significant figures in A? And it's time for you to do one. How many significant figures are in that number? All right, let's do it. And here we have all non-zero numbers are significant. So that's 1, 2, 3, 4, 5. Oh, look, we have a 0. It's in between 2 non-zero numbers. So that's also significant. So we have 1, 2, 3, 4, 5, 6. So this would have 6 significant figures. Oh, let's do another one. Here's one more for you to try. And I see everybody writing answers now. And if you'd like to, you can. You don't have to in the chat, but let's do it. Notice we have lead zeros. These are not significant. All non-zero numbers are significant. And a zero here in between confined to non-zero is, so that's 1, 2, 3, 4. 4 significant figures. Let's continue on with zeros. Now, trailing zeros, those as zeros at the end of a number, are significant if a decimal point is present. So trailing zeros are significant if a decimal point is present in a number. However, trailing zeros, those at the end of a number, are not significant, not, oh no, I made not disappear, not significant if the number lacks an explicitly shown decimal point. So let's take a look at that. When you have a decimal point at the end with zeros, they are significant. When there's no decimal point, they're not. And if we look at the following, and I'll do this one, we have a decimal point here. It's explicitly shown. All non-zero numbers are significant. There are 3. Oh, we've got zeros, and they're at the end of a decimal point. So these would be significant. And therefore, this would have 5 significant figures. Oh, let's do another one, make it interesting. And if we have this number, how many significant figures? Oh, look, there's a 0, but it's the end, but there's no decimal point. And therefore, this is not significant. But all non-zero numbers are 1, 2, so this would have 2 significant figures. Now, I won't get to it today, but Friday, I will have an exciting true life story of your host, me, Dr. White, and significant figures. You'll just have to wait till Friday to hear it, but it's going to be worth coming to class on Friday to hear that. All right, your turn. How many significant figures in the following number? All right, looks like everybody's done, so let's get to it. All non-zero numbers are significant. 1, 2, 3. Oh, look, I have a decimal point. Zeros at the end with a decimal point are significant. So 1, 2, 3, 4. This would have 4 significant figures. Remember, in real life, this is important. And for you, if you don't know how to do this, you're going to lose a lot of points on all the tests in the final. All right, let's see if you're up to the challenge. How many significant figures in this number? All right. Anybody need more time? I'll give you 6.2 seconds. 3, 4. I got a slow clock today. 5, 6, 6.1. Time's up. All right. Lead zeros when there's a decimal point are not significant. Non-zero numbers are this one, this one, this one, this one. Notice we did have and do have a decimal point, and zeros at the end with a decimal point shown are significant. This has 1, 2, 3, 4, 5 significant figures. Oh, let's do one more. These are fun. And here's one for you. And yes, there is a decimal point explicitly shown. All right, let's do this. All non-zero numbers are significant. Here's one, here's one, here's one, here's one. Oh, look, we have a decimal point. Zeros at the end with a decimal point are significant. So this is significant. Oh, we've got another zero, but notice it's confined between two non-zero numbers. So this is significant. So we have 1, 2, 3, 4, 5, 6. So this would have 6 significant figures. And that's how you determine for a number if it's significant figures. Now, once you have determined significant figures for a number, sometimes, like always, just about in our class, you may have to round off a number. When you do a multiplication, division, or addition, you have to learn how to round off. And this is the process for deleting unwanted, otherwise known as non-significant digits from a calculation, which you will be doing in this class. Trust me, you will. Now, there are rules for this. The first digit to be deleted, if it's 4 or less, simply drop that and all following digits. If the first digit to be deleted is 5 or greater, that digit and all that follow are dropped, and the last retained digit is increased by 1. Now, these rules are set up for a number that's in scientific notation, the first part. It's a little more interesting if it's not, but for this class, that's all we're going to do. So I'm going to teach you this way. So let's look at what do we have to do. Now, notice this number I just wrote has 5 significant figures. What if you had to round this off to 3 significant figures? How do you do that? Well, you start at the beginning, keep the first non-zero number, which is this 1, the next significant figure 2, And the next one, this is 3. The number to round off is the one after the last number, significant figure you want to keep. Notice this is 5 or greater. You drop this and this and increase this by 1. So the answer is that's 1.77. Let's do that again. How would you round this one off to 2 significant figures? And I'll do that, and then I'm going to let you have some fun, if not today. All right, keep the first significant figure, keep the second one, the next number you use to round off. And I put a double squiggly line so you can see that. You don't have to do that on a test, but this helps focus your attention what to look at. Is that number 5 or greater, 4 or less? And time's up. Hopefully I'll pick 4 or less. Therefore, this I'm going to drop and everything else afterward. And this would be the answer to 2 significant figures. That's how you round that off. And why don't you try this one? Round that off to 3 significant figures. Now, I do have something to let you know. This is not the most exciting thing in the world, but it is very important. And Friday, I'll talk to you about how this was, knowing this and my knowledge of this helped save a company I was working for about $170,000. And I was able to do that because I knew significant figures and how to round off. Yep, 170,000. That's a lot of money. So be sure to come to class on Friday or you're going to miss a real exciting story. All right, let's round this off to 3 significant figures. Keep the first significant figure, the second, the third, the one after the last significant figure you're going to keep, or exact number, really, not significant, significant figure, is this number. Is that 4 or less or 5 or greater? 5 or greater. You drop that and everything else. And because it's 5 or greater, the number in front you've increased by 1. So this would be 1.67 to 3 significant figures. And that's how you round off. Now, if I look at the clock, oh my gosh, we're just about done. Time flies when you're having fun with significant figures and rounding off. But a couple important things. Don't forget, we have class on Friday at 10. You don't have class tomorrow, so yay, you get to run away and don't have to be bothered by Dr. White. Hopefully I'm not bothering you, but you get tomorrow off from me. But Friday, please come at 10 a.m. And with that, I will remind you, if you don't have one already, get yourself a calculator. These, the TI 30XII Solar S, they're inexpensive. They're really good. You got a fancier one, that's okay. Next Tuesday, I will teach you all, if you don't know already, how to use this with scientific notation. And we'll also do some more scientific notation. Don't forget tonight, if you have any questions at all, like on the lab or anything else, stop by my office hour, which is at 5 to 6:15 on Zoom, a different login. And with that, oh no, I went over almost a whole minute late. I'm sorry. With that, I'm going to say, Gehen gesund, goodbye. I'll see you Friday morning.